YouTube channel. So in our last class, we talked about the application of the laws of indices, and we were able to apply this law in solving some problems in mathematics. But in today's class, we're going to continue with this exercise. Now let's start with the first question. The first question says, evaluate 4 raised to the power of 3 over 2. We're going to apply one of the laws of indices, and which is the word fractional index law. The fractional index law is what we're going to apply it. And the fractional index law says that when we are having what a base with an index of what of fraction with different values. Now the denominator is going to be the what the root. Or in this case, our denominator here is going to be what square root. If the denominator here is 3, that will be cube root. But in this case now, our denominator here will be the what the square root of what of 4. Now the numerator will be what our index raised to the power of what of minus 3. Now the square root of 4 here is 2 raised to the power of what of minus 3. Now 2 raised to the power of minus 3 can be re-expressed recurring from the law that we discussed earlier, the negative index law. Now the negative index law can be re-expressed as 1 over 2 raised to the power of what of 3, which implies 1 over 8. So 1 over 8 is simply our final answer. Or if the option is not expressed as what as 1 over 8, the option could be expressed as what 8 raised to the power of what of 1. That is still what the final answer. Now let's move to the second question. The second question says we should evaluate 3 whole number 3 over 8, close the brackets, 1 whole number 2 over what over 3, exponential 1 whole number 2 over 3. Now to solve this particular question, this is a mixed fraction. What we need to do is to change the mixed fraction to improper fraction for easy evaluation. So let's go. So we start with the first one, which is what 8. 8 times 3, and 8 times 3 is going to give us what 24. 24 plus 3, that will give us what 27 over 8. We just change this word to an improper fraction, and we also need to change the index as well to what improper fraction. So 3 times 1 is 3 plus 2, that's what 5 over 3. So this is what raised to the power of 5 over 3. Now what we are still going to apply here is still what is still our fractional index law. So in a case whereby we are given what different bases or different value in the bracket, so we are meant to apply our product law. But in this case now, there is no different variable. Instead, we only have the fractional value given in the bracket. So here we are meant to apply our fractional index law. So all we need to do is to find the cube root of each number in the brackets, because this particular index is applied to all the number in the bracket. So we go by saying cube root of what of 27 over cube root of 8. Now everything raised to the power of what of 5. Now cube root of 27 is going to give us what? It's going to give us 3. 3 times 3, that's 9. 9 times 3, that will give us 47. Now 3 raised to the power of what of the 5 given here over the cube root of 8 is also 2. 2 raised to the power of what of 5. Now, provided the examiner wants you to leave the answer like this, of which no examiner will want you to leave the answer like this, you still need to solve for that. So all we need to do is to find the value of 3 raised to the power of what of 5. 3 exponential 5. Now, what will that give us? That means you have to find 3 in 5 places. If you have to express it in an expanded form, that's 3 times 3 times 3 times 3 times 3 divided by 2 times 2 times 2 times 2 times 2. This is also what 5. Now 3 in 5 places, that will give us 243, and 5 and 2 in 5 places, that will give us 32. Now provided we can still simplify further, if we have any number that can go in this value without any remainder, we can go simplify further. But no number will go in 32 and also go in 243 without a remainder. So 243 over 32 is going to be our final answer for the second question. Now let's move to the third question. So question 3 says we should evaluate the square root of 245 q raised to the power of 3 q raised to the power of minus 2 divided by 5 q raised to the power of 5 and q raised to the power of minus 6. So we are asked to evaluate this. Now don't forget this square root is applicable to all the value in the square root. Now to solve this, let's consider the value given here. Can 5 goes in 245? Yes, it can. It can go 49 times. So we have 49 q raised to the power of 3 q raised to the power of minus 2 over q raised to the power of 5 q raised to the power of what? Minus 6. Then we still have our square root. Now, we still solve further. We need to consider this division sign given here. So let's make use of the division sign. So we have 49 p raised to the power of 3. Now we have a division sign. So if you are to apply the division law of indices, the division sign of the index is going to change towards to minus. So let's subtract the index now. So p raised to the power of 3 minus 5, q raised to the power of minus 2 minus minus 6. So let's put this minus in brackets. So we solve further. We have our square root 49 p 3 minus 5 is going to give us what? Minus 2 q minus 2 minus minus 6. Now minus times minus, don't forget this law that minus times minus we always give you what? Plus. So we are going to have minus 2 plus 6. Now minus 2 plus 6 is going to give us what? 4. It's going to give us 4. So don't forget that the square root of 49 is 7. Then we have p raised to the power of minus 2 times this square root now is applicable to all the values in the square root. So we have 1 over 2. So my square root can also be expressed as 1 over 2. Don't forget the root power law. So we have 4. So we have q raised to the power of 4 times 1 over 2. 2 will cancel out 2 here. 2 here. 2 here is 2. So I'm going to be having 7 q raised to the power of minus 1 q raised to the power of 2. Now to simplify further, I can say 7 times this p raised to the power of minus 1 can be expressed. Recurring our negative index law, I can express this as what? 1 over p times q raised to the power of 2. So our final answer will be 7 q squared over p. It's going to be our final answer for question 3. Now let's move to the fourth question. Fourth question D says evaluate 5x raised to the power of 3 divided by 25 x raised to the power of 6 close bracket raised to the power of 1 over 2. Now if you take a look at the question here, to solve this question, we are going to apply 3 to 2 laws of indices here. So the first law we're going to apply here is the root power law. And the second law is the division law, and the third law is the product power law. We're going to apply product power law and the root power law for the second expression. Now let's solve this first expression, which is the product power law. Now for the product power law, we're going to distribute the index given outside the box all through the value given in the box. So we have 5 raised to the power of 3 times x raised to the power of 3. That is for the product power law. Now divided by 25. Now let's distribute this index given outside the brackets all through. So we have 25 raised to the power of 1 over 2 times x raised to the power of 6 times 1 over 2 raised to the power of 1 over 2 again. So we have 5 raised to the power of 3 times x raised to the power of 3 divided by, now this will change to what? To square root. That's root power law. To apply the root power law, we have what? The square root of 25 times x. Here now, this is a multiplication fraction. So we just simplify. 2 here 1, 2 here is what? Is 3. So we have x raised to the power of 3. So we can solve further by saying 5 raised to the power of x times x raised to the power of 3 divided by square root of 25 is 5 raised to the power of 1 times x raised to the power of what of 3. So let's apply our division law of indices. So we have 5 raised to the power of 3 divided by 5 raised to the power of 1 times x raised to the power of 3 divided by x raised to the power of what of 3. Now, since their bases are the same, we are going to subtract the what? The index. So we have 5 raised to the power of 3 minus 1 times x raised to the power of 3 minus 3. 3 minus 1 is going to give us what? 2 times x raised to the power. 3 minus 3 will be what? Will be 0. So we have 5 raised to the power of 2 times 1. And that will give us 5 raised to the power of 2. And 5 times 5, 5 times 5 is going to give us what? 25. So 25 is going to be our final answer for the what? For the fourth question. The fifth question says evaluate 2y raised to the power of 0 times open bracket 3y raised to the power of 2 close bracket raised to the power of minus 3 times 7 raised to the power of 0. So don't forget, we recall that for the zero index law, anything raised to the power 0 is always what? 1. So we're going to be having 2 times what? Times 1 times. Now let's apply our product power law here. For the product power law, we're going to distribute this exponential minus 3 all through the what? The value given in the bracket. So we have 3 raised to the power of minus 3 times y raised to the power of 2 times minus 3 times 1. 7 is raised to the power of 0, so it will be 1. So we have 2 times, this will be 1 over 3 raised to the power of 3. Don't forget our negative index law. Times, now, y raised to the power of 2 times minus 3 will give me what? Minus 6. Will give me minus 6 times 1. This does not have what? Any significant value, so we leave it like this. So we still solve further by saying 2 over 3 raised to the power of 3 times 1 over y raised to the power of 6. Negative index law again. So our final answer here is going to be what? 2 over, now let's find the value of 3 raised to the power of 3. 3 times 3 9. 9 times 3, that will give us 27. So this will be 27y raised to the power of 6. That will be our final answer. So if you have been enjoying our classes so far, kindly subscribe to our YouTube channel, share with friends, and press the notification button to see every new video we're going to be dropping on this channel. So now let's move to another aspect of what? Of the application of the laws of indices. Now, this particular aspect we're moving to now is going to involve decimal number. How to solve an indices question that involves decimal number. Then after that, we're going to move to the exponential equation of indices.